Today I'm going to be building this, my very first 8S drone. Yeah, this thing is going to take 8S power. Most drones these days only go up to 6S, but nowadays more and more electronics like this T-Hobby Velox stack, they support up to 8 cells now. And so I want to build one and make a really fast drone. That's my main reasoning behind doing this. I want to get into the speed drone world, and a lot of those speed drones run more than 6 cells in order to get the most speed out of it. And so I'm going to start off with a fairly tame build, I think. So here are all the parts that I selected. The main core of it is this new Velox stack from T-Hobby. It goes up to 8S. Before it was only 6S, but this new one supports 8S, and it has a 70 amp speed controller. That's pretty crazy. Let's take a look at it. So here is the flight controller. So the main difference in making a flight controller support 8S is, I believe, in the voltage regulators over here. Flight controllers have 2 voltage regulators. You can see one here and one here. One of them is the 5-volt regulator, and the other one is, I believe, the 10 or 12-volt regulator. And to make this 8S rated, I think they have to increase the voltage rating on the capacitors. And so that's what they've done. A minor update, but still useful in order to support the full 8S. And let's dig out the speed controller, which is down under here. So here is their new 8S 70 amp speed controller. That's pretty crazy. Now, to make the speed controller support up to 8S, there has to be a lot of upgrades. So not only the capacitors, but also the MOSFETs, I believe, have to be upgraded a bit. So they have to be using some pretty nice MOSFETs on here in order for this to support 8S and 70 amps at the same time. It's looking a bit shiny, so I think they coated it with some kind of waterproof material or something, so nothing shorts out on it. So I guess that's good to see there. I also want to take a look at the filtering capacitors, because that's another thing that they have to adjust for 8S power. So let's see what they give us. Oh, we get 2 different ones. So I guess we have a 1000 microfarad 35 volt one. So I think that's the stock one for if you're just using 6S. But if you're going for 8S, you need a higher voltage rated capacitor. So I guess that's why they give these 1000 microfarad 50 volt capacitors. So I'm definitely going to be using that one because I'm going to be going for 8S. That's the flight controller stack. Now let's actually take a look at the motors. So for motors, this is another kind of issue when it comes to moving up in the higher voltages, because most motors are also only rated for up to 6 cells. So these are Emax motors. I got Pro 2808 1350 kV motors. These ones, I believe, are only technically rated up to 6 cells, but for many motors, since they're just coils of wire and magnets, you should be able to overvolt them a little bit as long as you keep the temperatures down. And so I think maybe I might underprop this a little bit, because I think these are originally intended for like 7-inch props, but if I use 5-inch props, maybe I can get away with using 8 cells on these motors. I got these in 1350 kV because I wasn't sure, again, about if I would fry these on a higher kV, so I kind of played it safe and went for 1350 kV. If this ends up turning out well, then I can always bump that up, replace these with the higher kV value ones. Now for the frame, I'm just going for a generic Mark IV 7-inch frame from AliExpress. These are only like 15 bucks. Super cheap, and I think they just work okay enough. In this case, unfortunately, they've been sending out HD versions of these frames lately, so they have 20mm wide camera spacing, but in the end, I don't think it's going to matter. I'll get into that later. But yeah, Mark IV 7-inch frame. I'm choosing the 7-inch so that if I do end up propping up later, I can always move on to 7-inch props if I need to. I'm going to start out with 5-inch props, though. I have an Express LRS receiver. Finding cheap Express LRS receivers these days is getting tougher and tougher. Before you could find like the SpeedyB Express LRS receivers for like $8, but now they're like $15 due to the tariffs and stuff. So I'm trying out this one. It's an HPX GRC. Never heard of that brand before, but these Express LRS receivers are only $6, so I'm gonna give that a shot and see how it goes. For my video system, I'm going for Walk Snail. I was debating on which one to do, but I think I really like the quality of digital video over analog. So I think for this video, I'm just going to go for this Walksnail Mini 1S Lite system. This isn't a long-range drone, so this Mini is going to do just fine, and I'll probably 3D print some adapters or something, because this is normally for like more smaller drones, but there's no reason I can't use this in a larger drone, just with a couple of adapters. For batteries, I'm using CNHL 2200 mAh packs, 4 cells, and I'm using 2 of them in series to get 8 cells. The 6-cell version of this pack is my preferred pack for 7-inch drones, so I figure that these 2 4S packs, they'll be good in this 8-cell speed drone. Also, I'm just a big fan of CNHL because their packs are affordable while still being good quality. Alright, so here are the props I'm going to be using. These are GemFan Vortex props. These are relatively new, and they're really high pitch. So for now, I'm going to be choosing these GemFan 5.25, so 5-inch diameter by 8. So 8-inch pitch. That's a crazy high pitch. Let's take a look at these. Yeah, look at that pitch. That's a crazy pitch angle like that. Like I said earlier, this is going to be a test bed for like a future high-speed drone project. And the crucial part about high-speed drones are the propellers. It's kind of like the most important part of a race car is the tires. Well, the most important part of a high-speed drone are the propellers. So I'm going to be testing out some of these Gemfan Vortex props. These are the highest pitch props I can find, just 5 inches in diameter, so these should be able to spin really fast. But with an 8-inch pitch, that's gonna really move the air at a high speed, and so that should hopefully result in the drone moving at a high speed as well. I think I'm also missing one thing. A GPS unit, because I want to measure how fast this drone goes, of course. I'm not going to be breaking any speed records with this drone, but I'm still curious to see how fast an 8-cell drone with those really high pitch props can go, and so that's why I'm going for a GPS unit. All right, so I think that's all the parts I need. Let me shove these all to the side real quick. A lot of people have been asking me about which tools I use for building FPV drones, and so I thought I'd highlight a couple of them. So first of all, here's a pretty cool screwdriver I picked up recently. These are just $12 on AliExpress, and basically I like this kind of screwdriver because it just looks pretty sick. Look at that. It's a fully metal anodized aluminum, and you get these in a bunch of different colors. I have a green one here, and I also have a blue one downstairs. It has replaceable tips, so right now I have the little Phillips screwdriver tip in there, but you can take out the tips in the handle, and you have the full set of hex drivers that you need, so 1.5 all the way up to 3. So those are all the main sizes you need for FPV drones, so that's absolutely perfect. Pretty cool and high quality for 12 bucks. Next, for soldering, I use the Pine-Sil soldering iron. These are computerized irons, which makes soldering super simple. If there's like one thing you can do to improve your soldering skills, I think it's just getting one of these computerized soldering irons. Don't use like the cheap pencil irons because those don't sense the temperature and they can't ramp up the heat enough. But these irons, they actually have a temperature sensor all the way up built into the tip. So the moment you touch your iron to a circuit board or something, the circuit board will absorb all of that heat, and then this iron can compensate by pumping out more heat into the tip to keep the temperature up to melt the solder. That's why these computerized irons are so great. And finally, I have 2 new tools to add to the collection. Shout out to Vampire Tools for sending me these. So first of all, this is a screw extractor slash plier. And the thing that caught my eye about these is that these are all made in Japan. And so the quality on these are absolutely insane. So these are their 5-inch mini stripped screw removal pliers. And wow, the tolerances on this is pretty cool. And the idea behind these is that if you have a stripped screw, they have this little round jaw in here, so you can grab onto the screw and unscrew it. So I'll be testing that out later. But yeah, made in Japan tools are always really good quality. And also they sent over this solder sucker, the world's best solder sucker. So if I make a mistake in the soldering, I can use this hopefully to get rid of any of those mistakes. So again, I'll be taking a look at that later. And of course, these are also made in Japan. There we go, made in Japan, so you can expect the quality to be top tier. Anyways, let's get on with the build. First things first, let's assemble the frame. These frames never come with instructions, but I've built so many of these over the years that now I think I have it down to a science. So here's the top plate, here is the bottom plate. There's no direction on that. And I can do a quick little dry fit just to see how everything's gonna go. So here's the camera plates, here's the top plate. Have these arm plates that go over here. Then we have 4 arms that just go on just like this. All right. First things first, let's organize all the screws because these really cheap frames, they don't care too much about the building experience. So higher quality frames, they're gonna be individually bagging and labeling every screw. But these cheap $15 frames, you gotta do it yourself. But not too big of a deal. I will say, missing from this particular frame is a battery pad. Most of these 7-inch frames come with a little rubber battery pad over here, but this one is definitely missing it. Bad luck, bad quality control, I guess, from these $15 frames. Can't complain too much. All right, let's take a quick look here on the layout. So standoffs are going into here, narrow at the front, wide at the back. That means this plate over here, this upper brace plate, we want narrow, empty slots at the front. We want narrow, empty slots at the back. These 4 really long screws are for the flight controller. These 4 slightly shorter screws are for the screws over here, 1, 2, 3, 4, that go through the standoffs. These slightly shorter even so screws, I believe, are for these press nut screws over here, and I think that's going to be our very first step. And then we have a whole bunch of these flathead screws for the top and bottom plates. Those are flush, so the battery won't run into the screw heads. So I'm going to start with these screws down here, going for the ones that go into the press nuts. I'm just going to lightly screw it in place, not all the way, and then I'm going to grab the longer screw. Let's slide that up in here. There we go. So the shorter screw should sit relatively flush with that press nut, and the longer screw is for this standoff over here. Now we just have to repeat this for all 4 arms. Alright, that's the base frame with the 4 arms in. One thing I am noticing about this frame is that there aren't any press nuts for the flight controller stack mounting. On these slightly better quality versions of these frames, there's going to be press nuts to really hold these screws in place, but this one there aren't any. So I might have to use my own M3 nuts over here to make my own makeshift press nuts to hopefully make sure there's not too many vibrations going into the flight stack. So a little bit disappointing for this frame. It's really a luck of the draw as to which one you get. Here's another random build I have. This is a work in progress. This is another 7-inch Mark IV frame, but because there are so many clones of these, you never know which one you're going to get. And this one does have the press nuts built into the bottom plate over here. So this one is a slightly better quality one. This one I'm using right now doesn't have those press nuts. All right, now we just need the reinforcing braces on here. So here's the back one. It's just this very small reinforcing brace. I'm going to use the slightly longer flathead screws so that they're flush in the back here. And time to do the same with the front. So here's the front brace piece. I think this adds strength to the frame or something like that. So let's use these longer flathead screws and tack them into place with the same standoffs. Alright, so there's the frame mostly assembled. I could go ahead and put the camera plates on up in the front here and then put the top plate on, but I'm going to be working directly with this to put all the electronics in, so I'm going to skip that for now. I'll leave those off, and I'm not even sure if I'm going to be using these camera plates because I'm going to be 3D printing a custom camera mount for my walk snail system, so I might not even be using those. So let's put all those off to the side, and now let's focus on the motors and the flight controller. Alright, the flight controller, it comes with a whole bunch of different size gummies. We have long gummies and short gummies. And I'm also going to have to figure out the orientation of which way I want the wires to come out. I also need to figure out which way I want the drone to face, because usually this side is the front with the camera mounting plate and you put the video transmitter in the back. But that's not actually going to work for this Walk Snail Mini, because the Walk Snail Mini is designed for like toothpicks and tiny whips, so the camera cable is actually pretty short. So I might actually make the back of the drone the front of the drone, if that makes sense. I'm going to make this side the front because I can more easily mount this Walk Snail Mini up in the front here with a custom 3D printed part or something. And I could just leave the back blank, or I could just put the GPS unit in the back, I guess. Yeah, I guess I could have the battery wires exiting over here. I want to leave a lot of the top space open so I can mount the batteries. So I don't want to route the wires through the top plate. So I think I'm just going to put the wires in the back right there. And then there's the matter of the capacitor. So let's break open the capacitor. The capacitor is going to be especially important for a build like this. So actually, most of the space in this drone frame might end up being used for the capacitor in the back here. So I can mount it. Yeah, I might make it like this. So the capacitor is sticking out here in what used to be the front of the drone, and that's going to be just sitting right there. So I think that's going to be my plan for now. So let's go ahead and mop things up even further. I won't be using the small capacitor because that's for 6 cells. It's kind of hard to tell which way is front when it comes to these things, so let's plug the speed controller and the flight controller together. Some people have been asking, how do I know which parts are going to fit together and half of it is reading the specs. So I know that most flight controllers are 30mm spacing, and this frame has 30mm spacing holes. So I know on paper the specs will line up. The other half of it is just trying it like this, just to make sure it'll fit. Because sometimes you're going to get stuff that doesn't fit. Maybe these contacts will touch the frame in some places. I don't know. For that stuff, it's just kind of down to luck and checking if anyone else has done a similar thing. Alright, that's all the long gummies installed in the flight controller stack. So that's going to go just like that. I'm curious if the stock screws are going to be long enough to do what I want with these. I don't think so. These are a little bit on the short side, so I'm not going to be using these 25mm long screws. I think I'm going to replace them with 30s and then use my own hex nuts in order to make like a makeshift like press nut and hopefully get rid of any vibrations. All right, so here's the plan. Stock screws, 25mm long, a bit short. I have these longer 30mm screws. And that'll go up into these frame holes here. And if those were press nuts, then I could just screw them in and I'd be done. But now they aren't. I can't use them as is, because now if I put them through the flight controller, it's very wobbly, and I think that's going to result in a lot of vibrations getting into the flight controller. That's why the press nuts are there in the first place. But I can kind of make my own makeshift press nuts by first putting a nut on the screw and cinching them down over here. So let's try it. Let's go ahead and tighten that down. Yeah, that's much better. So now with this nut clamping down, this screw is much more secure, and I'm not going to get a lot of vibrations in there. So I think that's going to be the way to go. Let me actually make this permanent right now. So let's unscrew it. I'm going to use some blue thread lock over here from Harbor Freight. Just going to put a tiny dab of it. This is just like an RC turnbuckle wrench. It's kind of handy for holding these nuts in place. All right, 1 down, 4 to go. All right, there we go. We have a nice solid set of standoffs over here. Maybe 30mm might be a little bit on the long side. It looks like it just barely clears this top plate here, but I think it'll be okay. Now let's mock up putting the speed controller on, and then the flight controller. And that is a pretty solid and secure connection right there. The capacitor I'll solder to the underside of this board, I think, just like that. And then the main power lead I'll solder to the top side. And let me find some heat shrink over here, because carbon fiber is conductive, and I don't want this capacitor to be sitting down here touching this carbon fiber plate and shorting out right there. So let me find some really thin heat shrink to cover that up. Slide the black heat shrink on the negative side with the stripe, red heat shrink on that side. Let's shrink it together. That should be a decent amount of insulation there, so it's not going to short out against the frame. And let's just double check the spacing on this. So if I solder it right up there, yeah, the capacitor will be able to sit nicely right in that slot. Awesome. Let's go ahead and bust out the soldering iron and get this all prepped. Here is my soldering setup. I don't think I'm going to need these arms. Let's take these arms off. I'll post a link to my soldering setup in the description below. All these little tools are super helpful in getting a nice solid connection. Got the circuit board mounted there. Maybe I will need a helping hand or two to hold this thing into place. All right, I'm going to start off by tinning the capacitor leads. Then I'm going to tin the pads. Now I should be able to bring them together and solder them together. That looks pretty good, so let's solder in the negative end. The ground or the negative end is going to take a little bit more heat because the ground planes on these speed controllers are pretty big. It's a pretty solid connection right there. I'm going to start by tinning these XT60 leads. Technically they're already pre-tinned from the factory, but who knows what kind of solder they use to tin it. So I'm just going to use my own solder and just re-tin it all over again. Now let's tin these sides of the pads. You know what? I probably should have done the battery leads first and then the capacitor leads, because I think the capacitor leads are falling off just due to the heat. Lessons learned, I'll do the battery leads first and then I'll do the capacitor leads. All right, pretty solid connection over there, nice. And there we go, another nice, easy, solid connection. This pine sol soldering iron really works wonders. If you don't have one, you really need to get one. It makes soldering these big connections just so much easier. All right, let's turn it back around upside down, because I think the red capacitor lead moved a bit when I first heated the pad up from the other side. Let me just fix that just by heating it up and pressing it down again. There we go, just like that. All right, that's the initial soldering done. Let's bring out the frame again and let's do a test fit just to make sure it's all gonna fit exactly how I wanted it to. So this capacitor side is going towards the bottom. Lay down right over there in that channel. And yeah, that's a pretty solid fit right there. I have to bend the battery leads up just a bit to make some more space. I think I could use just a little bit more in the height department. So I'm going to stand off these screws just a little bit more by threading on another set of hex nuts over here just to give it a little bit more height. All right, now the nuts are double stacked on top, which raises the height a bit, gives me just a little bit more room. And yeah, that is a perfect fit right there. That's looking good. I can drop the flight controller back on. You can see the drone starting to take shape. That's how the flight controller is going to be mounted. And once again, this side is going to be the front of the drone. That side is going to be the back. Next up, let's go ahead and take a motor and let's mount the motor in place. Looks like the motors come with M3 by 6mm screws and M3 by 8mm screws if you're using motor protectors. I'm going to skip the motor protectors for now, so I'm going to use the shorter M3 by 6mm screws. So there's the motor screwed onto the arm. Now let's say, for example, when screwing one of these motor screws in, that I did it wrong and I stripped out one of these bolt heads. What do you do then? And that's where these vamp pliers, screw removal pliers, can come in handy. So if you round out the heads on one of these screws, these vamp pliers, they have these little serrated jaws on these rounded ends. And so I can just go in and grab the top end of the screw. It's literally just grabbing the head of the screw using the little sharp tips of the vamp pliers, and I can unscrew it. Just like that. So the tips are all hardened steel, so it can grip onto the screws, and you can easily take out a stripped screw head without actually needing to use the hex screw on that. A pretty cool tool in my opinion, the jaws of these screw removal pliers that can grab onto the head of any screw and just unscrew them even if they're scripted out. All right, the motor's in place. Let's go ahead and figure out how to solder this to the speed controller. First, I'm figuring out just how long to make each of the wires. I want to make sure that each wire has just enough length to be tidy, but not too long. Let's tin those motor wires. And now let's tin the pads. Now, let's say, for example, that I accidentally mess up. There's way too much solder on the pads there, and so that's where I can use a tool like this, a solder sucker, in order to remove the excess solder. So let's give this thing a shot. So I can start by charging up the solder sucker by depressing the plunger. And if I press this button, the plunger releases and it sucks the excess solder up through the silicone tube and into this chamber over here. And later on, I can unscrew this and I can empty out the chamber full of solder balls. But that's the idea behind getting rid of all this excess solder. So let's give this a shot. So I'm gonna charge up the solder sucker. Now I'm gonna heat up the soldering pad to melt the solder, and then I'm going to use this to suck it up all out. That huge blob of solder pad was sucked up by this thing. That's pretty cool. Let's do the same thing for this middle pad over here. So I'm just going to charge up the solder pad. Oh, and there you can see all the solder. It's sucked up right there. That's so cool. I can see it right here. So that's what it does. It takes that melted solder and it sucks it up into the tool. Let's do it again for this soldering pad. So yeah, this Vampire Tool solder sucker, it's made in Japan, so the quality is very good. This thing is all metal besides that silicone tip up there, so it doesn't burn up. Yeah, very high quality solder sucker. Pretty impressed by this. All right, that's one motor soldered on. Time to repeat the same thing for all 4 motors. Next, I'm testing for shorts using a smoke stopper. This will trip if there's a short, but in this case I get a green light, so I'm all good to go. Alright, those are the motors all wired up. I'll tidy up the motor wires later with some tape, but next I think I want to wire up the Express LRS receiver, or maybe I should do the Walksnail video system, I'm not too sure. Let's take a look at what wires the T-Hobby stack gives us and see what we have to work with. So there's a set of wires for the Express LRS receiver. We have a DJI O4 cable. Let's see if I have enough camera wire here that I could just plug in the Walksnail video thing. Yes, I do. So as long as I turn the flight controller around, so before I had it like this, but if I turn it around just like this, I should be able to plug in this Walksnail video cable up into the top half of this O4. Yeah, power ground RXTX. So yeah, this Walksnail should be plug and play into the DJI connector. Now I just have to mount this Walksnail transmitter over here in this side of the drone frame. So that's great, no wiring required up there. I just had to figure out the Express LRS receiver as well as the GPS unit. The Express LRS receiver should plug in up in the side over here, because there's 5 volts ground, RX and TX. So let me go ahead and wire that one up. Looks like the receiver comes with wires, but I'm not going to need that because the T-Hobby stack comes with the wires I need. All right, let's get this Express LRS receiver soldered up next. With the receiver all wired up, now it's time to install the Walksnail VTX into the drone. I'm using M2 screws to screw the main transmission board into the frame. Alright, here's my 3D printed little attachment for the camera. This should just clip right onto the standoffs, at least hopefully it'll clip. Alright, that's not too bad. That's a pretty good friction fit. It's a little bit on the tight side, but I think that'll do okay. And then I should be able to screw in the camera to the side like that. Oh, awesome, this is gonna work. Let me find some screws. These are just M2 by 5mm screws, and so these should be able to screw right on in there. I'm gonna take apart the standoffs, I think, to make it a little bit easier on me. Alright, now let's see if the screws will fit through the hole. I just gotta screw it into the camera. And there we go, that's not too shabby, I think. A nice little camera mount. The only thing is, I just better not crash with this because there's no camera protection at all, so I'm going to definitely avoid crashing this drone. The only other thing I have to do is I have to mount the antenna somewhere. You know what? I could just mount it off the side of the camera plates like this. I can 3D print something that screws on through the top here and holds the antenna in place. I think that's what I'm going to do. Alright, and here's my updated little antenna mount, so it just slides onto the antenna there. I should be able to screw it into this standoff, and temporarily I'll just screw it in straight into the standoff for now, but later on I can screw this through the top plate as well. See the little antenna being held on into place. I almost forgot. Let's plug in that Express LRS receiver as well. And I think I'll actually mount this Express LRS receiver up here on the arm. That way I have all the main antennas towards the front of the drone, and the rear of the drone is free for the GPS, since these GPS modules are pretty sensitive to radio signals, so I want the GPS to be completely away from both of the transmitting antennas over there. There we go. And surprisingly, this is, I guess, everything this drone needs to fly. I don't know if I should install the GPS unit right now or not. I guess I should install the GPS while I'm at it over here. All right, it's time to set up this drone. So here's the drone itself. I'm going to set it on top of this USB fan over here to keep everything nice and cool while I set it up on the bench. I have it hooked up just to a power bank over there. I'm going to start off by binding the Express LRS receiver. So let's turn on my Radio Master Pocket.
Welcome to HTX. Designed acro mode on.
Let's find a battery. It's going to use a little 4S battery for now. The Express LRS receiver is down there. I'll wait 1 minute for it to go into Wi-Fi mode. You can kind of see the reflection of the LED light there, so it's blinking green. I'm going to wait for the green light to flash rapidly. That means it's going to be in Wi-Fi mode. Alright, that green light is flashing rapidly, so I should be able to connect to the Express LRS Wi-Fi network with the password Express LRS. There it is, Express LRS RX. I'm going to connect to that. It's going to automatically open up 10.0.0.1. This is the Express LRS's local Wi-Fi web page. I'm going to enter in my bind phrase, and then I'm going to do save and reboot. Okay, so the bind phrase is now in the receiver, so I'm going to do a power cycle. I'm going to unplug it, and then plug it back in. And now it should connect to my radio with the telemetry bars. There we go. I get telemetry bars in my radio. The LED is a solid green, which means it's bound to my radio. So that's how I like to do the Express LRS binding. Next up, let's connect the flight controller's USB into Betaflight. There we go. It's connected. The accelerometer is enabled but not calibrated. I'll calibrate it in a second. The very first thing I do whenever I get a brand new flight controller is I go down here to the CLI, then I make a backup of it. So I'm going to start off by doing a full backup by typing in dump. And so that spits out all of the settings of the flight controller. So if I ever mess up and I need to start off from scratch exactly how it came from the factory, I can copy and paste this dump file back into the CLI and restore everything exactly how it shipped from the factory. So there's the dump, and I'm going to hit save to file, and I'm going to save it to my computer. Then I'm going to clear the output history. Now I'm just going to do diff, so this is just the differences from the default settings. This can be a little bit shorter. You can see there's not much different from the stock settings, so it's only this much. This is kind of like a minor, like incremental backup. Okay, and with that I can disconnect and then wait for it to reconnect. Let's go ahead and calibrate the accelerometer. The drone is already pretty much level, I'd say, so I'm going to calibrate it right here as it is. All right, it's calibrated. What else do I need to do? Let's go into the receiver tab and make sure I hooked up the receiver properly. So let's go ahead and jiggle the sticks just to make sure. Uh-oh. The receiver is not responding, so maybe I have to set it up in the ports. If I remember correctly, I believe the receiver is set on UART3. Yeah, none of these are set up as serial RX. So I believe if I check UART3 as serial RX, I'm pretty sure that's what I set it up as. Save and reboot, and now let's try jiggling the sticks. There we go. Okay, so it was UART3. I just need to set it up in the ports tab. We get all the sticks. I have it set up. So my arming switch is up here. It's aux1. I have angle mode on aux2. So let's go into the mode sections and let's set that up. First, let's double check to make sure there's already nothing set up. Yep, there's nothing set up. So I'm going to do aux1 for arm on the upper end. Then angle mode on aux2 on the upper end. Okay, that should be it for the mode section. Now let's try the motors. To set up the motors, to make it a little bit easier, let's actually move the drone over so that it's pointing in the same direction as it's going to be normally. So the front of the drone is pointed like upwards, so that'll make the configuration a little bit easier. So let's go over to the motors, and let's do reorder motors. So I need to tell the drone exactly which way. Oh, you know what? Actually, the very first thing we have to do is we have to set the orientation of the flight controller. I forgot, because you see the arrow is pointing this way. So I have it reversed from what it normally is. So right now the flight controller by default thinks the front is this way, but actually the front is this way. So I have to do a 180-degree flip. So let's go into configuration and roll pitch yaw degrees. That should be 180 degrees. Let's do save and reboot for that. And now let's go and look at this little diagram here to see if that matches up properly now. So let's tilt it back, it tilts back, let's tilt it forward, it tilts forward. Left, right, yaw, left, right. Okay, so we did that. Now we can go over to the motors. I could do the reorder motors. I understand the risks, and let's do the motor order. Now I just have to click which motor is spinning, which is this one. It's there, that one, and that one. I'm gonna hit save on that. Now it's time for motor direction. Let's go over motor direction. I understand the risks. Do the entire wizard, and let's spin them all up. Now let's go through each of the motors. This one should be spinning clockwise, and that's spinning clockwise, that's correct. Let's go over this one. This one should also be spinning clockwise. That one is also spinning clockwise, that's fine. This one is counterclockwise, and this one is incorrect. So number 3 is wrong. It's spinning clockwise, but in the diagram it should be spinning counterclockwise, so I'll click that. And that'll spin. Now it's spinning counterclockwise. So great. And finally, this motor up here should be spinning counterclockwise. That's spinning the wrong direction. So I can hit number 2, spin it the other way. And now it is spinning counterclockwise. Perfect. So all the motors are spinning in the right direction. So I'm going to hit stop motors and close. So that's motor order and direction all complete. Let's see what else we have to do. Let's set up the walk-snail video system on UART2. So I'm going to go over to the presets tab. I'm going to type in walk-snail. I'm not connected to the internet right now, so I'm going to connect to the internet real quick, and then the presets should load. Okay, I'm connected to the internet, so I should be able to go back over to the presets tab. And it should load a bunch of presets, I believe. So there we go, OSD for DJI and Avatar, that's what I wanted here. And I'm going to set that to UART2, I believe. So I'm going to do set MSP VTX on UART2. I'm going to hit pick. Then I'm going to do save and reboot. All right, so if I go over to the OSD tab, it should be set to HD OSD. Let's give it a second to initialize. And actually, this isn't looking like HD OSD. This looks like the NTSC one. So this is a little bug with Betaflight. So I'm going to save this real quick, but I'm going to disconnect and I'm going to restart Betaflight configurator because sometimes this bug happens where the HD OSD doesn't apply. Like these elements look way too big for an HD screen. So I'm going to disconnect. I'm going to close Betaflight, reopen Betaflight, connect again. Now let's go over to the OSD and see if that fixes it. Nope, it still is wrong, so maybe you have to do a full power cycle. So let's disconnect. Let's unplug it. Unplug the USB first, then unplug the power. Then I'm going to plug the power, and then I'm going to plug the power back in. Now I'm going to plug in the USB. Okay, now I should be able to go into the OSD tab. Now, hopefully it looks like HD. It still doesn't. The video format is set to HD, but the screen definitely isn't. So I'm curious to see what's going to happen. I might do a bench test of this later. Maybe it's because I don't have the walk-snail avatar thing plugged in right now. So that might be it. I'll visit that later again after I plug it in. But there's one more thing I have to set up. It's the GPS. So the GPS is set on UART5. So let's go back over to the ports tab, and UART5 under peripherals, I'm going to do GPS or sensor input. I'm going to do GPS. I'm going to do save and reboot. Now hopefully if I go over to the GPS tab, awesome, I do see GPS data over here. All's left is to set up the VTX properly, the walk-snail VTX. So now I'm going to actually plug it in because this entire time it's not plugged in because I didn't want it to overheat. So I wanted keep the amount of time that it's plugged in as low as possible. For some reason, it's not giving me the HD OSD layout. I don't know why. HDSD PAL HD. Oh, there you go. I just have to toggle it between the other ones and then HD. So this is what the HD one properly looks like. That's what I was wondering about. So I just had to retoggle it, I guess. So now I'm free to go ahead and mess with all of this. And I do want quite a lot of data. So I want the battery average cell voltage, the battery current draw. So the warnings and the battery average cell voltage are in the middle because those are the most important. And then I want stuff like the current draw over there. Yeah, that's looking pretty good. Okay, so let me save that. Let's go over back to the motor section because I want to enable the bidirectional D-shot. I forgot to enable that before, I think. Yeah, we want D-shot. I don't think I need D-shot 600. I'll do D-shot 300 bidirectional. We'll do agree. There we go. And we'll do save and reboot. It's all set up in Betaflight, so now I just have to put the drone all together again, and I should be all set to go. Awesome. All right, it's time to tidy the drone up, starting with the motor wires, which I since forgotten to tidy up. So I'm using this fabric electrical tape, I believe. The official name for this is something like acetate cloth electrical tape, but it's this really nice sticky tape, which is awesome for wires. So that's why I'm going to use it here for the motor wires. I'm going to cut off 4 lengths of this. Alright, those are the motor wires all tidied up. It does look a lot cleaner now that they are. And now let's start putting everything back together. Everything has its own place except for the GPS module, and I'm still not exactly sure where I want to put it. So for now, I think I'm just going to start screwing it back together, and I'll go from there and try to get a good vibe on where it should be. All right, now where does the GPS live? I'm tempted to put it right here because I think there is plenty of space right here for the batteries, and so I think I could stick the GPS unit at the back of the drone right here, away from all the other antennas. All right, this thing is really coming together now. Look at that. Now I'm gonna finish putting thread lock on the screws because I never ended up doing that. So the motor screws and stuff, those aren't thread locked. All right, it's time for one of the last steps of the build. Just got to put the propellers on. All right, and there it is, all complete. Very strange looking drone for sure, but it is a drone. Kind of looks like it's backwards because it is. So there's the front there with the Walk Snail avatar camera, and there's the back over here with the GPS unit. I just need to strap a battery on it. For its first flight, I might just take it easy and do 6 cells for now, and then afterwards I'll do the 8S setup. I think that's going to be my plan, but it's going to look something like that. Pretty cool. I hope this thing flies, and I'm really curious to see how fast this is. Alright, it's a bit of a windy day today. Hopefully this thing can do a quick little hover test. Alright, here goes nothing, I guess. Let's arm it. Oh. That sounds crazy. All right, it's flying. The noise from these high-pitched props is so loud. There we go. Can it blow leaves around? Very own leaf blower. All right, success. Pretty cool. This thing is ready for a full test. All right, here goes nothing. Let's fly it for real. Ooh, 100 kilometers an hour already. Okay. $120. $130. Pretty cool. Oh, I think I'm gonna need more space. Even this isn't enough, I think. $130 kilometers an hour. Not bad. It sounds crazy. $130 kilometers an hour on 6 cells. I think I'm gonna need to up the camera angle quite a bit. Now let's try a larger 6 cell 2200 pack and see how this one does.
And acro mode.
Ooh, 140. Nice.
Angle mode.
Let's increase the transmit power on my walk snail system.
And acro mode.
150. Nice. 6 cells, 150 kilometers an hour. I don't even have enough space to go really full out, so I think on 8 cells I can definitely hit 200 maybe. Alright, we're at 6 satellites, so that's enough to go. So let's give this a shot. Fully charged battery. Alrighty.
And acro mode.
Just do a quick little range check first. Make sure I can make it all the way down here with no issues. Looks like that's no problem at all. I think I can only get 1 or 2 good passes out of this. I'm getting a weird little shake in the drone there. I'm not sure what that is. A little concerning. It's not too windy today either, so it's just a little concerning, but let's push through it. Alright, let's go. Full throttle. Oh, I lost GPS satellites. What is that? I don't know how I lost satellites there. $170 kilometers an hour. That's pretty crazy. That's a success, I'd say. Pretty good for success. Let's swap out the batteries. It was a little concerning that I was losing GPS signal mid-flight. And so that's probably because when flying, I go like this. And so the antenna is no longer pointing upward. So I might have to mount this GPS antenna at an angle next time. That's for the next version.
And
Let's go for one more pass.
acro mode.
All right, let's do this. Oh, 190. Wow. I think I was already hitting low battery at 190. Pretty easily hits 170. Occasionally hits 190. 190 kilometers an hour. And now it's time to switch to an 8S battery. Now previously I was using an XT60 connector on 6S, and even on just 6S that connector sparks quite a lot, and it's going to spark even more on 8S, which is why I'm choosing to swap the XT60 connector over for an anti-spark XT90 connector. This connector has a built-in resistor and spring system in the battery connector side that reduces the amount of current inrush. Like when you first plug it in, it reduces that initial surge of current so that it doesn't spark. And so I'm going to be wiring that into my drone, replacing the original XT60 connector. Also, 8S batteries are pretty hard to find, and I don't even have a charger that can charge 8S batteries. Yeah, every single one of the chargers I own, it only goes up to 6S. So what I'm going to do is I'm going to use two 4S batteries in series. That's how I'm going to make my 8S battery. That also means I have to make my own custom series harness. So the harness I'm going to make is going to have the XT90 anti-spark connector on one end, and on the other end, I'm going to have two XT60 connectors. That way I can hook up the two 4S batteries in series in order to make a single 8S battery. And so when I plug it in, I get no sparks. That's pretty awesome. Now I'm designing a GPS mount because when I was flying at the lake, I actually lost some GPS signal when I went full throttle because the drone goes horizontal, and so the antenna no longer points towards the sky. And so I designed this 3D printed GPS mount that'll angle the GPS at a 45-degree angle. So whether I'm level or fully horizontal, the GPS still has a pretty decent view of the sky. And now it's time for its very first flight on 8S. Let's fix my telemetry setup. So I want to actually record the max speed, and I believe I can do it from here. I just need to set up G speed max, G speed plus. Okay, so that's gonna log and keep track of my maximum speed throughout this entire time. So right now it's pretty much 0, and hopefully that'll be 200 by the end of this run. So this way I don't have to go frame by frame on my goggles. I can just look at the radio to see my true maximum speed. Battery is a little bit loose for my taste, but hopefully that'll be good enough just for this one quick flight. 14 satellites. I think we're all set to go.
Armed. Disarmed.
Whoa. That was not good.
Disarmed.
Should I take off from the grass?
Armed. Disarmed.
Okay. I don't know what popped. It looks like the capacitor lead is disconnected somewhere though on the negative end. It's time to head back to the bench for an autopsy. It turns out that the capacitor lead did indeed melt completely. The negative end just evaporated and is completely loose, and so it's time to replace the old capacitor with a new one, and I think my mistake might have been leaving the capacitor lead legs too long. Because I left the lead so long, it added resistance, and because the 8S power is transferring a lot of power in and out of the capacitors as it's flying, it heated that up hot enough to melt the leads. To replace the capacitor, I went on DigiKey, which is an electronic component supplier website, and I bought a really high quality Nichicon capacitor. This was $5, which is pretty expensive for a capacitor, but it's a very high quality capacitor with a low resistance, so hopefully this should be good enough to handle all the crazy voltage and current spikes from this 8S setup. And of course I'm going to solder it in place with very short leads. Because the capacitor is so big, I'm going to rearrange the frame of my drone a little bit. Right now the arms are like up into the frame, but I'm actually going to reverse it and I'm going to move the arms to the bottom of the frame, which leaves the inside of the frame where all the electronics are completely empty and free, which will leave room for this massive capacitor. First up, a quick test on 6S just to make sure everything else is still working properly and that the drone is still flying. And then another test on 8S power, and this time the drone does fly on 8S successfully, no fried capacitors here. And now it's time to finally take this thing out to the lake for a true 8S speed run. I'm gonna have to wait until it gets satellites. Once it gets satellites, I'll do a line of sight hover test. Once the line of sight hover test is good and it doesn't explode, I'm gonna go ahead and try a speed run with it. Hover test is good. Here goes nothing. Whew. $197. Whew. Didn't break 200, darn it. I really wanted to break 200.
Angle mode. Disarmed.
Max speed 197 kilometers an hour. Let's see what our radio says. Our radio says maximum speed 192. So a little bit of a discrepancy there. Pretty impressive. I'd say that's not too bad for my first attempts at an 8S speed drone. 193, 197, not sure which one to trust, but that's pretty fast. Surprisingly though, it doesn't seem like it's faster than on 6S, so I might have to tune the power system a little bit. I have seen that there are 6x12 props available now. These are 5x8 props, so these are only 8-inch in pitch. I say only, look how crazy that pitch is. But there are 6x12 props out now, and so I'm starting to think maybe I'll try that and see how fast it'll go with that. So there it is, my very first 8S drone, but I'm sure it's not going to be my last. It's been a little bit of a roller coaster ride, but I'm glad that I got it working and flying up to over 120 miles per hour. And it's been a really long video, so for all of you out there still watching, I hope you enjoyed this journey, and thank you for supporting my experiments in FPV drones. I'd really appreciate it if you could subscribe to my YouTube channel. Thanks for watching, and I'll see you in my next build.